Welcome, everyone. My name is Bo. I'm the Director of Growth and Architectural Relations at Acelab, and I have Dean Kauthen here with Cladiator, and they are going to be providing today's AIA presentation, Advancements in Cladding Support Systems, Design and Performance. Thank you all for joining us today. We're really excited to be offering this presentation. I believe this is one we've offered in the past, so if you are a return guest, thank you for coming again. And if not, we're happy to have you here and to be able to offer this again to our audience. I'm going to give just kind of a quick few minutes of information about, how to connect with our guests and how to do that right on Acelab's site. Just give folks a few minutes to join, and then we'll get started right away with our AIA presentation. So as I mentioned, I'm with Acelab. We are helping out with hosting this webinar today. Here's a quick snapshot of our team. So Acelab provides architectural resources for building product specification, and we are started by architects for architects. So our goal, is always to be able to provide tools and resources that help you design better buildings and design them, more quickly and more efficiently. And so we're really happy to be able to offer these great learning opportunities with Cladiator today. So, as an example, here are some of the kind of workflow problems that Acelab works to solve. And then I'm just going to quickly jump over to our live site, show you where to find Cladiator on Acelab, and then we'll go ahead and get started. So once you sign in, you can just, if you know what you're looking for, jump right over here to this top search bar, type in the name of a manufacturer that you're looking for, and then you can jump right over to their page on Acelab. So here you can connect with Cladiator directly. We'll also be asking you if you want follow-up information from them during today's webinar. So you can, either do this during the webinar today or answer our poll, whichever works for you. You can go ahead and nest that under a project or add a new project. You can select exactly the product that you're looking for, or you can skip this if you're looking for more general information. And you can also select exactly the type of information that you're looking for. So you can go ahead and do that anytime during today's webinar. Then when you head over to your conversation, you'll have a record of that here. An easy way to get in touch with Cladiator, send attachments back and forth, give some updates on your project information and all of that good stuff. All right. So with that finishes my kind of quick little intro. If we have some extra time at the end of today's webinar, I'll give you some more information about how to find and use Acelab, or find products and use Acelab in general. And a few housekeeping things while I am still here. So for today's AIA members, in order to give us your AIA number for credits, I'm going to send a link to a form. And just fill that out at any point during today's webinar or afterwards, and we will report the credits directly to AIA. I'm sending this in the chat now. And I'll also send this link at the end of the webinar, so if anyone misses it, don't worry. And if you have any issues, just give me an email. All right, and then the one other thing I want to mention is we will have some time for Q&As at the end of today's webinar. So please feel free to submit your questions during the chat, and we will get to them, during the webinar if we can. And we'll definitely have some time to answer them at the end. If we do not get to your question, then we will have a record of it and we can follow up with you after the webinar. And let's see, I believe other than that, that should be all of my housekeeping for today. So again, thank you everyone for joining, and I'd love to introduce Dean Kauthen. Dean, you can feel free to take it away with today's AIA-approved webinar.
Terrific. Thank you very much, Bo. And I will get started with our program. So a little bit about me. Waiting for the slide to change. Got a fairly long background in building envelopes, construction, really like to focus on energy efficient building designs. And I would encourage anyone, if they want to connect on LinkedIn, I'd be happy to do that. So who is Cladiator? Before we get into the program, really our parent company, which is Allied, based out of New Jersey, has about 30 years of experience installing facades and aluminum composite panels in the New York City area. So based on that, the innovations that we're going to see today are based on that experience over the last 30 years. So you'll see some innovative ways of attaching cladding. And the two systems that we're going to talk about today would be a fiberglass Z-girt called the slotted Z, and the insulation securement with that system is done with this little clip that we call the rocket stick. And then we also have the clip and rail system, which is the CL300. So those are the two basic systems that we're going to talk about today and how they compare to other products available in the market. And we are, as Bo said, registered with the AIA, as well as USGBC and others. So as we go through the program, I'll keep everything generic, and hopefully we'll have some good questions either during the program or at the end. So when we talk about this course, we're no longer talking about how cladding is attached. It's not just the question of transferring loads from the cladding to the building, and the type of support systems that we use can greatly affect the performance of the building. So we'll take a look at that in greater detail, as well as the advancements over the past 10 years or so in cladding attachment systems. So those are really the what the program's going to be about. So we'll look at the learning objectives. We'll talk about the differences between these different types of cladding support systems, how we can improve energy efficiency of our exterior walls. And we'll talk about, the correlation between design and maybe some of the load challenges of attaching different types of cladding to the structure. And then we'll look at ways of attaching panels to a facade, using fewer fasteners, less punctures to the waterproofing layer, and improving thermal performance. And then lastly, we'll take a look at some accessories that can make the architect's life much easier. So we'll start with the historical advancements of these types of systems. So going back to, say, like the 1950s, for example, starting off with steel Z-girts, and then moving into the 2000s, we've got polycarbonate choices, fiberglass, zinc-coated steel, and really the most recent evolution would be a fiberglass Z-girt with this built-in insulation securement. And all of these solutions could be used with or without additional rail profiles, which would be like a hat channel like we see here, or a Z-girt, or a metal Z channel. And then the clip and rail systems, likewise, we can see the difference from days of old, if you will, to today. So starting off in the late 1900s, we'd be looking at the metal bracket system. There's really no thermal break. Moving into the 2000s again, into materials like fiberglass, zinc-coated steel, aluminum, which is still available today, and aluminum with polyamide thermal spacers. So that's a little bit about the history. So we know that the energy code changes, and different municipalities, states adopt these codes at a different pace, at their own time frame. So what we're looking at here is the comparison of code adoption by state to ASHRAE 90.1 2019 version. So you can see places like Washington and Oregon, for example, as well as Massachusetts, really more on the cutting edge. They've really embraced the new codes, and they're really really more energy efficient than some of the other areas that have not been analyzed, like some of the states in the middle of the country, for example. And so we know as the climate changes, so does the ASHRAE climate zone map, just like it did in 2016. And you can see by the circles on the map that there are areas that are affected most by the shifting of these major climate zones northward, as maybe the temperatures around the world have started to increase. And in addition, subclimates have been added to account for example, warm and wet areas versus warm and dry. And these buildings need to be designed differently to meet the needs of each of those environments. So as the climate becomes more warmer and the energy codes become more stringent, the choices that we make for the materials that we use can work together to have a significant impact on whether or not we're accomplishing our goals. And of course, California, being California, has their own energy efficiency standards, which is also known as Title 24. So they've broken up the state into 16 different climate zones that represent geographic areas for which energy budgets have been established. And these energy budgets are the basis for those standards. So the California Energy Commission updates the building energy efficiency standards every 3 years by working with stakeholders in a public and transparent process. So this chart from the US Department of Energy shows a baseline energy consumption equal to 100 in 1975. And code changes implemented in the late 1980s reveal the first big drop in energy use. And since then, we've gone from that baseline of 100 to about 45% normalized energy use in commercial buildings. So we can see that the improvements of the energy codes are contributing to improvements in energy efficiency and reduction in energy consumption. So thermal autonomy, often represented as the fraction of time the building experiences active space heating and cooling energy demands. So a completely thermally autonomous building that requires no heating or cooling whatsoever would have a rating of 100%. So its indoor temperature would remain between 65 degrees and 77 degrees Fahrenheit. So shown here, a building constructed to code minimum requirements for energy efficiency has a thermal autonomy of about 30% based on equipment runtimes, while the high performance building enjoys about a 70% thermal autonomy. So the areas under and over the demand curves indicate the amount of heating and cooling energy respectively. So the high performance building yields about an 80% reduction in annual energy demands for space heating and cooling. So, and two important aspects of building performance emerge from this comparison. First, the capacities of the heating and cooling equipment for the high performance building are much smaller than for the code minimum building. So piping and ductwork, for example, will likely be smaller and less intrusive. And second, the run times of that equipment in a high performance building will be less than for the code minimum building. So this should translate into a longer service life as well as lower maintenance costs. And a building that's designed to provide thermal resilience will provide a week or more of comfortable indoor conditions, usually sufficient enough time to have the power restored. So with today's energy modeling software, buildings can be designed to take thermal resistance or resilience into account. And holistic approaches to design for thermal resilience also take into account the need for external shading devices to block excessive solar gains and provide effective natural ventilation to provide free cooling during heat waves. So thermal autonomy and thermal resistance are interrelated. The same enclosure characteristics that extend thermal autonomy also help achieve higher levels of thermal resistance. So active systems alone cannot extend thermal autonomy and resilience of buildings. They can only supplement energy deficits that are not covered by otherwise passive systems. So there are several components to managing enclosure heat flow, but today we can address the first two that we have shown here. We'll talk about continuous thermal insulation with minimal thermal bridging to achieve higher R values. And we'll talk about continuous structurally supported air barrier system to control air leakage. So when we talk about improving thermal performance of wall systems, we can look at the materials that we use to attach our cladding, some of which may have a low thermal resistance like galvanized steel or stainless steel, or a high thermal resistance, which also is a low thermal conductivity. So those materials would be fiberglass and polyamide and other plastics. So when we look back at the timeline, we see that there's been a shift from using those highly thermally conductive materials like steel and moving more into lesser thermally conductive materials like polycarbonate and fiberglass, and in some cases thermally broken aluminum. And we can see here in this visualization, there's two different types of clip and rail systems in plan view. So the example on the right is an example of a thermal bridge where you see the blue area representing the cold temperature on the exterior of the building around a steel clip transferring heat from the inside of the building out. And this can create an environment that's not quite as comfortable for the occupants and certainly not energy efficient. And then on the left, we see an example of a thermally isolated system where a more advanced cladding support system using a polyamide material, for example, that has a low thermal conductivity has successfully reduced the opportunity for heat loss. And note that the same principles are true in southern regions where the temperatures are reversed with hot exteriors and air-conditioned interiors. So looking at the graph of thermal performance comparison, we can see that the continuous vertical Z-girt, the one that we see here in green, for example, has a very low percentage of insulation effectiveness. And then as we go down and right, we can see that the different type of clip systems using different materials have a much higher thermal performance. So here we can take a closer look at how insulation is encapsulated around the clips so that have low thermal conductivity. And this gives you a very high degree of thermal performance. So continuous insulation around the building envelope plus incorporating cladding support systems that use materials with low thermal conductivity offer us the best and most effective thermal performance. And the orientation is going to depend on many factors. Some of it is engineering, some of it's the material that's being used to clad the wall. So vertical Z-girts, for example, that align with the steel studs may work structurally, but they can reduce the overall thermal performance of the wall system due to the continuous contact of the thermally conductive materials. And then horizontal girts, they can offer better thermal performance, but they can create some additional concerns for air and water movement. So we can summarize the thermal performance section with this example. So if we take a look at the first column on the left, the insulation thickness, that would be a mineral wool insulation. And we could use the 4-inch mineral wool as an example. So out of the box, it has a nominal R value of about 16.8. When combined with vertical stainless steel girts that are 16 inches on center, we would note then that the wall has an effective R value of about 10.3. So it's quite a reduction due to the thermal conductivity of that vertical Z-girt in continuous contact with the stud behind. We can improve that a little bit by using a horizontal stainless steel subgirt, 16 inches on center. And our effective R value has increased a bit from the previous example of 10.3. Now we're at a 12.2. So switching systems totally and using a clip and rail system that's thermally broken with vertical spacing of 24 inches on center, we can see now that due to the lack of thermal conductivity and the addition of air spaces within the cavity, we can actually get an effective R value of a 17.6 versus the nominal R value of 16.8 for the insulation alone. So this is what we often see on bid day. This leaves a lot open to interpretation as to how the cladding is going to be supported, resulting in a difference in the actual effective wall performance that this project would end up with. So because there are so many different ways to attach the systems, you could understand why there's a gray area. So when we receive documents that are, in schematic design or design development, and the contractors wanting pricing, there's going to be many different ways to get to the end. And some of those ways would just be with your standard vertical or horizontal Z-girts, or you might see, the vertical Z-girt with crossing girt, or a clip and rail system, or a variety of thermally improved systems. So there's many. So without having something actually specified or designed with the help of a manufacturer, you're going to get a variety of outcomes at bid day. And you can see that in this example here, that by changing the materials, different types of exterior cladding are going to require different types of cladding support. So left to their own devices, the contractor or the architect may end up designing something like this. So where you have kind of a clip and rail system on the left, and then, we need a vertical attachment point, so we'll add another one in the middle. And now this is really complicating the installation process. You're cutting insulation around all of these different support pieces that are on the wall. You're adding more holes to the membrane behind. There's additional labor, there's additional material cost, and you have the risk of increasing the depth of the wall system, something that may not be allowed or may not be in the design of the wall system that you're looking for. So something that works a little better, or actually quite a bit better in one manufacturer's opinion, is a coplanar system. So a system that allows for a variety of cladding on the exterior without increasing the wall thickness and without adding to the number of penetrations through the air-water vapor barrier. So with this type of a system, you can see that the contractor can easily install the insulation. There's fewer problems than trying to work around a variety of layered components. So an example that we see here with this basically a flush mounted system, we see that we have a vertical clip and rail system. And then at the area number 1, we see that there's a horizontal support that's added between the verticals, but it's in the same plane as the vertical supports. So those are only needed where, say, you have a maybe in this case a horizontal joint where you need to attach the panels. And then this area here at number 2, you can see that those supports are engineered. They're rather static. They don't have to be changed. They're independent of the cladding attachment on the outside. So what you end up with is this thermally broken system that has ease of installation of insulation and a predictable layout of support for your exterior cladding. So there's a number of considerations that influence what type of cladding support system that you're going to use. And one of those is the weight of the panel, the dimension of the panels, the depth of your exterior cavity, whether it's a rain screen or not. And then the facade materials themselves have requirements as to moving moisture and addressing fire concerns. So in general, the lighter cladding support systems like Z-girts are generally used with the lighter weight materials like metal, wood, fiber cement. And the clip systems tend to be quite a bit more robust. And those are used with very complex, lightweight panel designs, as well as with heavy materials such as stone and masonry. So when you look at cladding support systems, the direction that you're looking to go is for quick and easy installation of the facade materials in any configuration or angle that you wish. So here are some examples of using like a long, slim panel design. Here's one with shadow boxes that might benefit from a more versatile cladding support system. And likewise, you can see the mixed media used on these facades. So while each panel type is different, the structural support supporting the cladding can be the same underneath. So this is where we note that there's a structural and performance-based relationship here. So the choice of your cladding material and the depth of the total wall assembly will affect the strategy taken. So it's worth mentioning as it relates to how the system is constructed, for example, that this is really an area that there's really no straight line of consensus. And changing your mind on the exterior facade may have implications that you might want to be able to adjust for easily, which would be, maybe this clip and rail system versus a fiberglass Z, for example. And also noting the fire issue, we certainly need to address that. The systems that you're being shown today have been NFPA 285 tested. Excuse me, with mineral wool in one case, and there are other cases where you have polyiso materials that have their own NFPA 285 testing. But mineral wool is always a safe bet. So, as we mentioned earlier, there are systems that are non-adjustable, like the ones on the left, and and adjustable systems like you might see on the right. And looking back at the timeline, you can see that really only very recently have you seen more market developments, positive developments in the design of these systems. So much so that we're now really looking at that thermal conductivity as the improvement from previous types of systems. So depth of Z-girts and insulation thicknesses and air barriers all really have an effect on what type of a Z-girt that you might use. So those are available from about 1.5 to 6 inches in depth, in some cases up to 8 inches in depth. And then the clip and rail systems likewise can start at about 1.5 inches and go all the way up to 11.5 inches, and in some cases even deeper. And here are a few examples of adjustable systems that are available on the market. So you can see in the upper left, there's an adjustable system. When that built-in adjustment that you see circled is exceeded, a clip can be added to get a little more adjustment out of the cladding support system. So you might see this in today's new construction and possibly in yesterday's buildings, which would be like retrofit wall assemblies. And then in the lower left, you see another system that has some adjustability, as well as on the right side of the screen as well. So a system like you see here, this would be a clip and rail system. So this has greater adjustability with fewer parts and pieces. So you can see in the examples where you can have that you could push the T-track down into the clip, or you can pull it out, so you can get these varying depths using the same materials. So it's very adaptable to your project. So in a case like this, where we have, say, a metal panel, and you're looking for the reveals, it's the same parts and pieces, just adjusted differently to allow for the installation with reveals, having the same subgirt system in which to attach the panels to. Or likewise, if you wanted to go with a more coplanar look, you could use different materials in the same plane, and again, using the same cladding attachment systems. And quite easily, you see a very adjustable system on the right. So you can get plumb and level 10 feet at a time. Or you have the non-adjustable systems that you see on the left. That would be your typical Z-girt, and that would use a shim to bring you to plumb and level on your wall. And then there are other systems like we see in the middle that allow you to adjust each individual clip so that you can mount the rails in a plumb and level fashion. So ideally, you want a system where you have fewer parts and pieces, fewer fasteners penetrating that weather barrier behind. And accessories. So there's been some advancements in accessories that allow us to have more flexibility in the mounting of cladding to the building. And here's one example with the clip and rail system that has a recessed reveal option. And alternatives to brake metals. So you can see that there are extrusions available that can terminate, end wall conditions, head, sill, and jam conditions as well, all built into one integrated system. And we know that the deeper that we go with our wall systems, the more difficulty we are going to have supporting the corners. So know that the industry has taken steps to address those issues as well. Again, all designed from the ease of installation standpoint, from those 30 years of installation experience. So it's not an academic exercise. This is something that's available today to solve a lot of problems. And we know that troubles can occur when using, say, stick pins to hold the insulation in place on your wall. So adhesive fasteners, for example, cannot be installed in all weather. So there's a time also for the adhesive to cure. And not all sealants are compatible with all waterproofing of the walls. So especially in fluid applied waterproofing, you may have some compatibility problems using an adhesive for a stick pin. And likewise, mechanical fasteners, you're adding one more puncture at every point that you fasten a stick pin. So, and anytime we're touching that waterproofing layer, there's a chance of human error. So having an insulation securement system such as this one that basically uses a peg and slot method for securing the insulation is one way to overcome that. So no stick pins are required for this particular insulation securement. And we'd be remiss if we didn't address open joint rain screens. So we're seeing those in the market, and that can be accommodated by either using a fiberglass Z-girt with a UV facade tape like we see here. That fiberglass Z also comes in black in color from the manufacturer as well. And then using other components for the building envelope to give you that consistent dark background through your open joint rain screen is very effective. And lead credits, there's a number of possibilities. We know that aluminum and steel are very easily recycled. Polyamide, which is really a nylon-based product, is 100% recyclable as well. And in summary, so if we're using cladding support systems like these polyamide and fiberglass materials, they can significantly increase the thermal performance of a wall system. These adjustable systems are available, so you can have different wall cavity depths, you can mix textures and materials, and still have a very cost-effective solution in which to subcontractors can bid. And using these flush mounted or coplanar systems give you a great deal of attachment points. They're great for complex designs, but you don't necessarily have to add material across the entire facade. You can add them just where needed. And we know that fiberglass Z-girts have integrated insulation securement options, and you have a wide variety, a lot of choices of finishing accessories to help you with your terminations and corners and insulation securement. So that is the end of the AIA portion of the presentation.
Great. Thank you so much, Dean. I'm going to go ahead and let everyone know now is a great time to answer some Q&A into either the chat, or if you would like to raise your hand, I will unmute you and you can speak out loud. You do not have to put your video on, but I find that that's often, a fun way to have some more in-depth conversation. So feel free to do that as well. I'm going to go ahead and launch our poll. So if you would like follow-up information, you can just go ahead and answer that directly on our poll. And one moment, let me get that up. All right. All right, so that poll should be up now. There we go. I'm also going to re-enter the AIA sign-in in the chat box. So if anyone missed that form in the beginning, feel free to give us your AIA number on that form that I just sent now. Okay, cool. So let's see, for our questions, Gabriel asks, is the cost of these systems a factor for you, not mentioning single family residences?
The short answer might be yes. However, we are shipping the slotted Z-girts to builders of single family homes. So in designs or on projects that have a high thermal requirement, say passive house standards, we're participating in projects like that. Generally speaking, these higher end commercial type materials aren't found on residential projects, but we are, matter of fact, there's been a couple, one in Colorado, in Netherland up by in Bo's part of the country. And then we also have a customer in California who's making modular homes in the factory using these types of systems. So generally speaking, we don't see a lot of it, but every day we're seeing more and more.
And I have a kind of a question following up on that, but is that something that you see Cladiator like moving more towards? Kind of, yeah, like more of those single family residential opportunities? Or do you feel like it, yeah, kind of more makes sense for, you know, multifamily, or like when you have kind of like a larger, you know, plan of multiple cottages or that kind of thing?
Yeah, so I think you would see it maybe the other way around, and that would be residential approaching us as that market grows. Right now, it's probably rather small, but where we are seeing a lot of traction, especially in the Northeast, is with multifamily developers. So like in Massachusetts and New York, there are incentives for developers to build these mixed use projects that include residential in a much more thermally effective manner. So in that part of it, yeah, we are seeing quite a bit of interest.
Cool. Right, so this person asks, would you recommend vertical girts mounted against the weatherproofing aligned with the steel studs and horizontal channels to support the cladding?
I guess it would depend on the materials that you're using. It may be, and depending on the project and the details, that might even be redundant, as opposed to just using the thermally broken horizontal girt directly against the wall. So you have less chance of thermal conductivity when you're only attaching every 16 inches, as opposed to, you know, having that vertical support, you know, running the whole length of the stud.
Mm-hmm. Okay, cool. Also, I see we have Brian here, who is an attendee. Brian, did you have a question for us? We might have given him talking privileges by mistake. Okay, I'm going to hide you, and then just let me know if you have a question, Brian. I'm going to move on to this from David. Are there generic load tables to know what's appropriate for various claddings, and does it include attachments?
So really, we engineer each project individually. So I don't know, Sebastian, maybe if we have a load span table. I know it's something that we've talked about, just to make it, you know, a little bit simpler right off the website in order to figure it out yourself. But generally, in our case, we're going to we'll either do a lineal foot takeoff and pricing of, say, the Z-girt. The Z-girt's really designed to to withstand about 50 some pounds of dead load. So it's rather robust, but we can address that maybe offline. But as of now, we don't have a standard load span table.
Great. All right, I see Brian has raised his hand. So
Yeah.
let's see. Cool. Hey, Brian, what's up?
Hey, not much. Quick question I had. The areas where we have openings, for instance, thermal broken panels all around.
I think you might be cutting out a little bit, Brian. Are you having trouble hearing Dean?
Yeah, I couldn't hear him. I mean,
Okay.
I could hear noise.
Yeah, it sounded a little muffled, Brian.
Hey, can you hear me better now?
That's a bit better.
Okay, I'll try to keep it brief here.
Cool.
The areas where you have rough openings around windows, do you have special profiles, like L angles, for instance, that can serve as, say, containment angles for your insulation around the perimeter that can be thermally broken as a part of your system?
Okay, I see. So I'll just kind of recap that for those who couldn't hear. So I think Brian's asking about for rough openings around ducts, is there some sort of kind of finishing profile that you would have for that rough opening kind of moment?
Around
Yes.
windows, yes.
Yeah.
So for the clip and rail system, we would have something special, and then for the fiberglass Z-girt, there's nothing. There's no special shapes to address those openings. It's more of a which would be the same as maybe a galvanized Z-girt. It's not going to have anything special. So and it's kind of on par with that. Perhaps down the road, but we do have it for that CL300 system, which is that aluminum clip and rail.
Cool. Great. Thank you for talking, Brian. I love the bravery. Cool. All right. So from Jillian, is Gladiator based in the US? I do government work, and manufacturing or distribution is not permitted with certain countries like China.
Yeah, so we don't deal with China, and we are based in the US. We're based in New Bergen, New Jersey, or Bergen, New Jersey. Right next to the Lincoln Tunnel on the other side of Manhattan.
All right. So looks like that might be it from now, unless anyone has some additional questions. We've got a bit of time, so feel free to enter those or raise your hand. While we're here, I'm going to send over another link in the chat to everyone. This is for the Acelab event calendar. So this is a great way to just have these events put onto your calendar in the future. You can go ahead and subscribe to that. And then these webinars will just get automatically put onto your calendar of choice. So you can join us at our next one. Okay, well, thank you from Jillian. Thanks, Jillian. All right. So I'm going to give everyone a few more minutes to answer some questions, and or to enter some questions. And while we see if anyone else has anything to ask, I'm going to go ahead and just show everyone one more time how to get in touch with Cladiator on Acelab, just in case you missed that at the beginning. And of course, you can answer this poll that we have, and then we'll, work on putting you in touch with Cladiator's team for exactly the information you're looking for. All right. So one moment here and I'll share my screen. Great. Okay. And I'll actually just sign out and show you this from the very beginning. So now you can see I've signed out of Acelab. acelabusa.com is our address. If you haven't already made an account, very free and easy to do. So once I sign in, you can sign in with Google, so that's pretty quick. Once I sign in, I'm brought back to my dashboard. So you won't, go to that marketing page every time. You'll have a really, quick dashboard where you can pick up with everything that you're leaving off with. So whether that's searches that you've saved or just your regular search history, products that you saved, conversations and projects that you've uploaded, you'll get a quick view of everything you've been doing on Acelab here. All of our searchable product categories are up here at the top. So for cladding, you could head over to cladding and cladding support systems. And if you were looking for a more general search, you could get started here. So this is Acelab's product advisor. It's really a guided search tool, walks you through the process with, graphics and some additional descriptions. So if you're looking for some more, general research, or you're kind of looking to see an array of the products out there, the product advisor tools are a great place to start. And those are, again, always nested in this dark blue bar up here. We're also adding new products continuously. So check back in on this other products tab regularly, and you'll see some new products uploaded there. All right, so I'm going to just quickly go through this quiz, and let's see, there are only a few questions for cladding support because there's, not too many things we need to ask there, but here you can see a list of all of our cladding support systems that are thermally broken. You can see we have Cladiator here and the ability to connect directly with them from this page. You can also shortlist their products, so you can save them to a project or without a project to be able to navigate back to later. If you would like to skip that whole search process, if you know exactly what you're looking for, you can just go ahead and type Cladiator's name up top here. That works for any manufacturer on Acelab, and you'll be brought to a manufacturer's page where you can view product data and available products apples to apples across our site. So scrolling down, you can view the products here, jump to those product pages, save them right from this page as well. And then you can also reach out directly to Cladiator, nest that under a project. You can select exactly the products that you're looking for, or you can skip that, select the information that you're looking for, and then you'll have a conversation created on your Acelab account. So you can do that for any manufacturer on Acelab. It's a great way to get in touch with today's speakers, and then they will answer you over on your Acelab account. So you can find that by heading over to my library and going to conversations. You'll also receive email notifications as well as a little notification up here if you have a new message. But in your conversations library, you can filter this by project, or you can just view all of the conversations that you've had. And this conversation portal is a great way to connect with different product reps because it allows you to nest that under a project. You'll really easily have an overview of your project details here. So anytime you reach out to manufacturers using Acelab, you're not having to kind of continuously repeat project information or copy and paste an email in order to just kind of reiterate those same facts. Your project details are automatically saved, and anytime you reach out to a new rep, they'll be able to easily see an overview of that information. So that's kind of a quick tour of how to get in touch with Cladiator and how to use our search tools as well as our search bar. We've got a lot of project management tools as well as project portal and a digital project library over here. So if that's something you're interested in learning more about, feel free to shoot me an email, and I'm happy to help you set up your Acelab account, get some projects uploaded, and create a digital product library that works well for you and your team. All right. Well, so I see we didn't have any more questions come in. I'll give one last call for them. And if not, we can go ahead and let folks go a few minutes early today. But first, I just wanted to say thank you to Dean and to the team at Cladiator for today's presentation. This was really great. I always learned a ton about all of the considerations of cladding support systems from you guys. So really great educational webinar, and we're really happy to have you guys today. All right, cool. Looks like we're just getting a bunch of thank yous. So I will go ahead and end our poll for today. And thank you everyone who attended today's webinar. We really appreciate it. Before I end things, if you missed the AIA form or the form to sign up for our future webinars, that's just right in the chat. So copy over those links if you need to. And if not, we're going to go ahead and end today's webinar.
Thank you.
Cool. Thanks, Dean. Thanks, everyone.